to code EX501 Unit 1 DC Machine Part 1 Lap Winding Demonstrative Example. Here is an example in order to understand the winding diagram of a lap wounded DC machine. For that, let us consider a two-pole DC machine having four number of coils wounded in lap winding pattern. In order to do the initial calculation for lap winding, we need to find the back pitch, front pitch, and the winding pitch. For simplex lap winding, having a double layer winding and also slots containing only two coil sides will always have winding pitch of +2 for progressive lap winding. By putting the values for coil and poles in a formula YB equal to 2C upon P plus or minus K, we can find that the back pitch calculated is 5. From the given quantity of winding pitch +2, we can calculate the front pitch also, which is equal to 3. Before we understand the winding diagram, winding table is generated using these three basic quantities like back pitch, front pitch, and winding pitch, out of which only back pitch and front pitch will be utilized to develop winding table. As we know that in commutator machines, all the coil sides are double layered and divided into top layer and bottom layer. Top layers are always numbered odd and bottom layers are numbered even. In order to start the winding table, we may give number 1 to any of the top coil side of any coil and name it as coil number 1. So let us start our winding table assuming that we have named coil side number 1 as shown in the figure. If we know the coil side 1 by adding a back pitch of 5, we can get the bottom coil side of the same coil separated by 180-degree electrical. By subtracting the front pitch from the previous coil side, we can get the top coil side of the second coil. By utilizing this two quantities, back pitch and front pitch, that is, by the addition of back pitch to the top coil side and subtraction of front pitch from the bottom coil side, a winding table is generated. So for the second coil, the top conductor is 3 and the bottom conductor is 8. And the front pitch defines that the conductor number, coil side number 6 and 3 are connected to the same commutator segment, and coil side number 8 and 5 are connected to the commutator segment consecutive to the previous, that is connected to 6 and 3 coil side. When we get any number which is greater than the total number of coil sides present in the machine, then we subtract the highest number of coil side number from that given number and generate the coil side that is feasible for the winding table and design of lap winding. Like here, when we added 5 with the back pitch 5 number, we get 10. But since the total number of coils are 4, so there could be possibly only 8 coil sides. So we need to subtract 10 minus 8 and we get 2. In this fashion, we may continue to add back pitch and subtract front pitch, and gradually we reaches to the point from where we have started. This can be demonstrated using the coil sides placement in each slot as will be demonstrated. We started from coil side number 1. We can complete the winding diagram also simultaneously, and we reaches to coil side number 6 by adding the back pitch. We can complete the winding diagram, and here you can see the back pitch is clearly demonstrated and how the terminals of the coil is connected to the commutator segment. Next coil side 3, which is a top layer. We complete the winding diagram simultaneously, and also by knowing the second coil side or bottom coil side of the second coil and its position, we can complete the winding diagram for coil 1 and coil 2. Similarly, we can move ahead and complete the placements of these coil sides in the slot from the knowledge of winding table and complete the winding diagram according to the calculations made. And finally, we reaches to the same conductor from where we have started. So the last coil side was coil side number 4, which is again connected to the commutator segment number 1, from where the coil number 1 having coil side number 1 started. We can define comfortably the back pitch, also the front pitch and other winding pitches in the winding diagram also. After the completion of such diagram with more number of coils and poles, the winding diagram may also look like this, which is made for 21 number of coils and 4 number of poles.